Note 6.3 are in factoring trinomials by grouping. The first thing that it's asking you to do on your paper is to multiply the following binomials. Remember, you learned two different ways to multiply the binomials. You can either use the box or you could use the distributive property. I would prefer to use the distributive property here so you can understand where factoring by grouping will come from. So if you look right here, it says multiply the following binomials. 3x plus 2 times 4x minus 7. So I'm going to multiply 3x to 4x. I'm going to distribute it through, and that gives me 12x squared. Then I'm not done distributing the 3x. The 3x also needs to get distributed to the negative 7, and that would give me negative 21x. Okay, then I need to distribute the 2 to the 4x, and that gives me 8x. But I also need to distribute the 2 to the negative 7, which gives me negative 14. Then you have to see what like terms you can combine together. So you end up getting 12x squared minus 13x minus 14. Okay, so this is what you end up getting right here. Now, when you factor by grouping, basically what you are going to do is you are going to see what you can group the trinomial into so that you get 4 terms. So notice how there's 3 terms right here. This is a trinomial, but before we combined our like terms, we ended up with these 2 terms right here. So the question is, how do I make it so that I could get 4 terms out of the 3 terms? And that's really what's going to help you out when you factor by grouping. Once you're done factoring by grouping, you can just factor out what's in common with all of your different terms. Okay, so before we do this example right here, I want you guys to write on the top of your paper 2 things. The first thing that I want you guys to write is an example. So if you had x cubed plus 2x squared plus 3x plus 6. How do you factor by grouping? Well, to factor by grouping, you are going to group this into 2 separate expressions. So we're going to take the first 2 terms together as one expression, and then the last 2 terms together as another expression. So in the first expression, we've got x cubed plus 2x squared right here. So if I were to look at x cubed plus 2x squared, I'm going to factor out what's in common with those 2 expressions, those 2 terms, and I'm going to completely ignore what's underlined in red. So if I have x cubed plus 2x squared, the GCF, what's in common with them is an x squared. So I'm going to factor out x squared. What's left over is x plus 2. Okay? Then I'm going to do the same thing with my red expression. So my red terms are 3x and 6. So what's in common with 3x and 6 is 3. So I'm going to factor out a 3, and then I have x plus 2 left over. Okay, then once you've done that, if you notice, you have the same exact expression inside of your parentheses. So that's the GCF of this entire expression right here. So if you look at this entire expression right here, the GCF of it is x plus 2 because that's what's in common with both of them. So I would factor out x plus 2 here, and then I would just write out what's left over. Well, what's left over when I factor out x plus 2 out of this expression right here, I have an x squared left over. So I've got x squared right here, and then what's left over in this expression right here, when I factor out x plus 2, is a 3. So it's x plus 2 times x squared plus 3. So if you look back right here, our goal is to split this up into 2 separate terms, so that way I can start to factor by grouping like we did in this example up here. Okay, and I'll explain that a little bit more in detail with our examples that we have. But another thing that you need to write down on your paper that's really important for you to know is this expression right here. A quadratic expression, and we'll be talking about quadratics more in detail in the future, is always in terms of a, b, and c, and it's always going to be written out as ax squared plus bx plus c if we're looking at it in standard form. So ax squared plus bx plus c is really important. So for example, right here, the example that you see on your paper, it says 6x squared plus 5x minus 6. So this is our example that we're looking at. The a value is the 6, the b value is the 5, and the c value is the negative 6. So again, this means that a is 6, b is 5, and c is negative 6. All right, so let's figure out how to factor by grouping. All right, Step A, consider the product A times C. So A times C is going to be 6 times -6, which is -36. Okay? And then step B says to list out all possible factor pairs of A times C. So we're going to make a chart for 36. We're going to ignore the negative for right now, and we'll just make our chart, and we'll deal with the negatives in a couple minutes. So 36 is divisible by 1, so 1 and 36 is a set of factors. It's divisible by 2, so 2 and 18 will work. It is divisible by 3, 3 and 12 will work. 36 is also divisible by 4, 4 and 9 will work. It is not divisible by 5, but it is divisible by 6. 6 and 6 will work. I've gotten to a point where I'm repeating numbers, so I've covered all possible combinations of factors of A times C. Step C says to find the pair that satisfies the requirements of the product sum method. In other words, a pair of numbers whose product equals AC and whose sum is B. So if you remember, AC was -36, and we're looking for a sum of B. So are there any numbers in this set right here that would give me a sum of 5 somehow? So 1 and 36, it's impossible. 2 and 18, there's no way. 3 and 12, there's no way. 4 and 9, there is a way if the 4 was a -4. So if I had a -4 and a +9, it works for me because -4 times 9 is -36, and -4 plus 9 is +5. So that's what I'm going to use, -4, 9. And 9. So it says in step D, rewrite the expression with the same first and last term, but with an expanded B term using that pair of factors as coefficients. So basically, if the problem originally said 6x squared plus 5x minus 6, all I'm going to do is I'm going to copy down the first term, but I'm going to split up the B term into 2 separate terms using the numbers that we decided to use right here. It doesn't matter what order you use it in. You can say 9x minus 4x or -4x plus 9x. It's up to you, and then you copy down the -6. Now, remember, that just basically brings you back to this part right here where you have your 2 terms before you combine your like terms. So do you see how we're working backwards in order to bring us back to this section right here? Okay, so then we now have 4 terms that can be entered into a tabular model or factored by grouping. So let's do the last step. Pair the first 2 and the last 2, find out a common factor for each group. So I'm going to rewrite this down right here again. 6x squared plus 9x minus 4x minus 6. And I'm going to underline each section with a different color so you can see how this works. So we're going to factor the blue terms together first. So what's the GCF of 6x squared and 9x? The GCF is 3x. Okay, and then if I factor it out, I end up getting 2x plus 3. Okay, and then we're going to do the same thing for our red terms. So we have -4x and we have -6. Well, remember, if our leading coefficient is negative, we want to factor out a negative number here. So I'm going to factor out a negative. What's in common with -4x and -6? -2. And then when I factor that out, I end up getting a +2x and a +3. This only works if this and this are exactly the same. And they are. Our factors here are the same, and that's the common factor of this first expression right here and the second expression right here. So our common factor is 2x plus 3, and then we factor out what's left over. Well, there's a 3x left over, and then there's a -2 left over, and then I am done factoring by grouping. Okay? All right, on the next page, it says try the following examples. So in question number 1, let's identify what A is, what B is, and what C is. So if you could go ahead and do that, press pause and come back to me to see how you did, that would be great. Okay, so A should be 3, B should be -2, and C should be -8. Remember, because it's always in the form ax squared plus bx plus c. Okay, so our first step is to find AC. So AC is going to be 3 times negative 8, which is negative 24. So then I'm going to make a chart for 24. So let's see what are some factors of 24. Well, 1 will work, 2 and 12 work, 3 works, 3 times 8 is 24, and then 4 times 6 is 24. 5 doesn't work, but 6 works, and it's in our chart, so we've covered all possibilities. So remember, the next step is we have to find out which one of these factors will give me this value of b right here, this negative 2. So is there any way I can get a negative 2 from 1 and 24? Well, if I add them together, I would either get 25 or negative 25, depending on the signs. And if I subtract them, I would either get positive 23 or negative 23, again, depending on the signs, okay? So that won't work. 2 and 12 also will not give me a negative 2. 3 and 8 will not give me a negative 2, but 4 and 6 will if the 6 is negative. So we would probably want to use 4 and 6 with a negative on the 6. So then if I multiply 4 times negative 6, it does give me the negative 24 I want. And if I add them together, it does give me the negative 2 that I want. So remember, what we're going to do next is we are going to rewrite this problem so that, and split this negative 2x up into two factors that will add up to negative 2. So here we go. 3x squared minus 2x minus 8 is the original problem, okay? And we're going to copy down the 3x squared, and we're just going to split up this negative 2x using the two factors that we decided right here. So we're going to have a negative 6x and a positive 4x. Again, it doesn't matter what order you put it in, it's completely up to you. And then minus 8 right here, okay? And the minus 8 stays the same, okay? So I don't change that piece. Remember, this line is equivalent to this line. We're just breaking up our middle term into two separate pieces, okay? So then we have to factor by grouping. So we're going to factor this first part by grouping right here. So this is my first group. And the GCF of 3x squared and negative 6x is 3x. And then when I factor it out, I end up getting x minus 2. Okay? Then we're going to do the same thing with the second group. The leading coefficient here is positive, so my GCF is going to be a positive 4. And then I factor out the 4 and I get x minus 2. So what's in common? Well, we have x minus 2 in common. What's left over? Here we have a 3x left over. Here we have a positive 4 left over. So this is my final answer for this question right here. All right, let's take a look at number 2. Number 2 says 3x squared plus x minus 14. The first thing that I want you to do is to please identify a, b, and c, and then find out what the product AC is going to be. So figure out what A is, B is, and C is, and then what AC is going to be. Go ahead. Okay, so you should get that A is 3, B is 1, C is negative 14, and the product AC is 3 times negative 14, which is negative 42. Okay, so now we need to make a chart for 42. What are some factors of 42? 1 and 42 will work. 2 works. It's divisible by 2 and I get 21. 3 works because we just did it right here, so we got 3 and 14. 42 is not divisible by 4, so I'm going to skip that. It's not divisible by 5. It is divisible by 6. 6 times 7 gives me 42. The next number is 7, but it's in my chart, so my chart is complete. Now, which one of these factors will give me this B of 1? The only one that will work is 6 and 7, and that will work if the 6 is positive, or sorry, if the 6 is negative and the 7 is positive. So we'll have a positive 7 and a negative 6. So I'm going to go ahead and rewrite my problem, 3x squared plus x minus 14, and I'm going to split up my middle term. So my middle term will turn into 3x squared plus, this will turn into right here, 7x minus 6x. And then I just copy down the minus 14. Okay, so now I'm going to factor each part. Each group. So this is where the factoring by grouping will come in. So in my first group, the only thing that's in common with 3x squared and 7x is an x. So I factor out an x and I have 3x plus 7 left over. in the second group, the only thing that's in common, first of all, the leading coefficient is negative, so I'm going to factor out a negative value. And 6 and 14, the only number that you can divide them both by is 2. So then when you do that, you have 3x plus 7 left over as well. Okay, remember this and this have to be identical, those two parts of my factors. So that means that my final answer will be 3x plus 7, that's what's in common, multiplied by the x that's left over here and this negative 2 that's left over here. And then I'm good to go for this problem. All right, in question number 3, what I want you to do, please, is find out the a value, the b value, and the c value. Figure out what a times c is, and then make your chart for whatever a times c is and decide which two numbers you're going to choose. So please press pause and do this, and then come back to me to see if you got the right answers. All right, you should have gotten that a is 1 because the invisible coefficient in front of x squared is 1, b is 1, and c is negative 20. So then when you multiply a times c, you get 1 times negative 20, which is negative 20. Then your factor chart will look like this, and the only factors that you're going to want to use are 4 and 5. If you have a positive 5 and a negative 4, that will add up to a positive 1. So then we're going to take x squared plus x minus 20 and split this up into 5x and negative 4x. All right, and then we're going to copy the rest of the problem down. So then we end up getting our two groups. Here's my first group, here's my second group right here. And when you look at your first group, the only thing that's in common is an x. So I'm going to factor out an x, and then I have x plus 5 left over. Okay, and then in the second group, the only thing that's in common is 4, but the leading coefficient is negative, so I'm going to take out a negative 4, and then I have x plus 5 left over again. So then I end up having my common factor being x plus 5, and then I have x minus 4 left over.